Bismillahirrahmanirrahim. This is day 10 of our KAPS calculation, and today we will go through the chapter related to osmotic and isotonic solutions. This is a real small chapter, very simple, straightforward, no tricky questions, just a bit of formulas that we need to memorize, and that's it. Now, what is it all about? This formula, in this chapter, they will give us a substance, for example, NaCl. They will already have some solution and they want us to add NaCl to this solution to make it isotonic. Isotonic means isotonic to our blood. This is for the liquids that we need to inject in our bodies or eye drops, this kind of solution. So there will be a solution already made, composition will be given, and they ask us to add any substance, not only NaCl, any substance. Maybe they ask us to add dextrose, but add that much that it will make this solution isotonic. This is clear to everyone. What are we going to do in this whole chapter? We are going to make solutions isotonic by adding some ingredient, one ingredient.
Okay, sir.
Okay, this was the basics of this chapter. Now I want you to understand three terms here. They are really simple. The first one can be confusing, which is freezing point depression. This seems a bit tricky. What do you mean by depression, freezing point depression? We can simplify it by saying that this is freezing point, right? Freezing point value of some element. I'm not going really deep in all of three these: freezing point, sodium chloride equivalents, and isosmotic concentration. This is not the topic of this presentation. I'm here for the calculation. I will give you real simple overview of all of these three, and then we will dive into the calculation part. First of all, let's take a quick look at what is freezing point depression. The symbol for this is FD 1%. Do not get confused with FD 1%. It simply means freezing point depression. Now, the blood serum and lacrimal secretions, they freeze at 0.52 degrees centigrade. And in this way, we relate this temperature to other ingredients. For example, the normal saline NaCl is osmotic with these fluids. It also freezes at same temperature. So we will be using other ingredients in relation to their freezing points. Just keep this in mind, and we'll see it in examples also. That, for example, here they have given us this freezing point depression for the whole formula. So this way the values are going to be there. No need to memorize the values, and the values are different for all the elements. For example, this adrenaline acid tartrate, this have a freezing point depression value of this. Sodium chloride have a freezing point depression value of this. So kind of a thing, all these three, just like all the elements have their molecular weights, so they also have all of these three things. NaCl will have freezing point depression. NaCl will have a value of sodium chloride equivalent and isotonic concentration. First thing was this freezing point depression. We relate this point, we make a relationship between multiple ingredients based on their freezing points. Second thing is sodium chloride equivalents. We know that 0.9% is isotonic solution. So we will relate other ingredients of the solution with this sodium chloride in relation to the sodium chloride. The value of sodium chloride equivalent will also be given. Then the third thing we'll discuss is isosmotic concentrations. The symbol is CISO. For this sodium chloride equivalent, we say SCE, sodium chloride equivalents. And for isosmotic concentrations, we will use CISO, means isosmotic concentration. All of these values are going to be there. There is some theory in this chapter. The first page is theory. And when they talk about, this is about this freezing depression thing. And then there is a theory, small theory. when they talk about this sodium chloride equivalents. You can go through this theory and we'll have a good idea of what all of these three things are. But for the sake of calculations, I have just given you an overview of this. All of these values are going to be given in the formula, even in the question, and we are going to put these values in these kind of formulas. These can look complex, but they are actually very simple. Simple things repeating over and over again. So these three things, you are now familiar with these names.
Yes, sir.
Okay, just get familiar with the names. That's it. You will read the theory and you will be getting more details into these three things. Now remember, I want you to remember some values. We are going to be seeing these values in our formulas. For freezing point depression, we have read here in the book that blood and lacrimal secretions, they freeze at minus 0.52. Just neglect this this minus sign. There is a value of 0.52. So I want you to memorize this value 0.52 whenever we talk about freezing point depression. Second value is sodium chloride equivalent. Now 0.9% is normal isotonic concentration. So just remember this 0.9 with sodium chloride equivalent. And for isosmotic concentrations, just remember one, simple one. Now the units of freezing point depression is going to be degree centigrade because we are talking about the freezing points, it's in degree centigrade. For sodium chloride equivalents, when we compare other ingredients to sodium chloride, this will be in gram. And for isosmotic concentrations, there is going to be in percentages. The ingredients will be given in percentages. This is not important, just to have some idea that what is going to be the unit of all these three. When we have the value of isosmotic concentration of NaCl, this will be in percent. When we have NaCl value in sodium chloride equivalents, this is going to be in gram. And when we talk about the freezing point depression value of NaCl, we will be talking in degree centigrades. So very simple. This is just for concept. These three values I want you to remember. And these units, they are not really, I don't think they are going to confuse you in units in these type of questions. They are really simple. Now this is, I have just taken you through this point. Now let's take a look at the formulas. This is the formulas, total formulas we are going to use in our chapter. Very simple. Let us simplify this a bit, that what is this whole formula given. This percentage adjusting substance and 0.52 and just two values are here. The rest of the formula is on repetition. We will start from here. CISO, we know that CISO is concentration osmotic concentration. What is the freezing point? If the freezing point depression is given, we can find the CISO. This value is going to be the constant. As I have showed you that value with FD 1%, you should remember 0.52. So memorize it this way. With FD 1%, we will take 0.52 up here. In case of sodium chloride equivalent, we take value of 0.9 here. And for SCE, this is a different formula than these two. I don't think this is going to be part of your exam, but just remember it because the values are similar all over. To find SCE, sodium chloride equivalent, when they give you FD 1%, this formula will come as 0.9, 0.9 divided by 0.52. So values are same, just memorize this. Take an overview of the formulas, and when we utilize it, you will have full understanding of this. Now what's happening here? This is very simple. Percentage adjusting substance. Adjusting substance means the substance we have added in some solution. For example, NaCl is added in a solution. So this NaCl is here. Percentage adjusting substance. So we'll say NaCl is equal to, now if the values are FD1 are given, then we will be using this formula. If the values of SCE are given, we will be using this formula. If the values of CISO is given, we will be using this formula. What is this? 0.52. As we are using the formula for FD 1% values, we will be using this 0.52 here minus. This is very important, very easy to forget or confused with multiply sign. So you should be really concentrating on these signs in the formulas. Then we have, what is this? This is in a bracket, there is this percentage of A, this percentage of A substance. I mean, if there are multiple substances given, for example, NaCl, then dextrose, we take this as A ourselves, this as B, or you can take this as A and this as B, doesn't matter. So this A is some ingredient, percentage A, this is concentration of some ingredient in percentage. This is important to convert everything in percentage. If they have given you something in 1000 ml, this is 1 liter. So you need to convert this in 100 ml to put it here, because this is percent sign. Then multiply by its FD1 value. FD1 value of this thing. This will be given in the formula. And then again, we will repeat the same thing over and over again for all the ingredients. This is what this formula is about. This do not end here. If we have 3 ingredients, just put another plus sign and add this whole bracket for third substance as well. In the following formula, everything is same, just we have replaced 0.9 because now we have modified this formula for SCE, sodium chloride equivalent. We will be writing 0.9 here, and rest of the things are going same. This value is going to be in percentage, and then the SCE value of this ingredient is here. In the third formula, we have modified it a bit more. I think let's just start practicing so that you will have clear idea, and then we will come over this third formula. Things are confusing, and I know that you are not making perfect sense of these formulas, but let's start practicing and you will have it. We will be practicing this first formula, concentration isosmotic. What kind of question is going to be? Very simple. Show using the FD 1% method. Now, whenever you will have a look at this FD 1% or SCE or CISO, you should know that this question belongs to this chapter of these isosmotic concentrations. The FD 1% method, that strength of an isosmotic concentration of NaCl is 0.9% weight by volume. Now, what they have given us in the question, they have given us the FD 1% value of NaCl, just that, and we need it. Now they have not clearly saying about this CISO here, but they are saying the strength of an isosmotic solution means concentration of isosmotic solution, right? Strength of osmotic isosmotic solution or concentration of isosmotic solution is same thing. So they are saying they have given us the FD 1% value of a substance. Here NaCl is 0.576 degrees centigrade, as we have just studied. So we just need to put the value here in FD 1%, and it will give us the isosmotic concentration. This 0.52 is constant. This is going to be the same every time. So just put the value 0.52 divided by this FD 1% value of NaCl, and we will have a percentage of concentration, isosmotic concentration, that is 0.9%. Very simple. When you learn all these formulas, you will know what formula we are going to use to extract our answer. Moving forward. Now the second thing, second formula. In this formula, they are saying if the SCE value of anhydrous glucose is 0.17 gram, the SCE value is in grams. What is its CISO? Now this time they have clearly saying the value of CISO is required, and what they have given us is the SCE value of some ingredient. So we will use this formula this time. CISO, concentration isosmotic, is equal to 0.9 is going to be constant, and down here we write this in grams. If they have given you this in milligrams, you have to convert it. 2 grams. So you take care of the units here, my friends. 0.17, then the answer is here. Concentration isosmotic is 5.294 anhydrous glucose. Should be clear because there is nothing complex. You just need to remember the formula. Now, for the third thing, this is not important that much because we are finding the value of SCE by giving the value of FD 1%. Not very important for, I don't think even important for the perspective of KAPS, but as it is simple, so let's memorize it. What is the SCE of anhydrous glucose? And what is given is the FD 1% value. Here is some printing error, but this means FD 1%. And FD 1% is given, and we need to find the SCE. We only have one formula here to find the SCE, which is this. So put the values here, 0.9 is constant here, 0.52 is constant here, multiplied by the FD 1% given, and we will have the value of SCE, sorry. So, yeah, these three formulas will have very simple questions, only one value given and other is required. Is this clear up till this point, that where we have to use these formulas?
Yes, sir.
Bit confusing, but when you do
Yes,
it
sir.
with your hand on your register, it will be making more sense. Plus, you read the theory before solving the questions. Now we move forward. And this is as simple as these three formulas. Let me show you. I have selected three questions, one question from each topic, and there is no complexity in these kind of questions. Very simple chapter. First, we will go for quiz question 10.1. Here is this. So how they are going to be? The question is going to be very simple. Let's read it. How much NaCl is required to render 100 ml adrenaline injection BP isosmotic? Just like we have learned that we will be given one substance and we need to add it into some other solution to make it isosmotic, isotonic. So this is what they are saying, isosmotic or isotonic. So NaCl we need to add. So this percentage adjusting substance is NaCl is equal to. Now what values they have given here in the first question I have selected, they have given the value of this FD 1%. There are two total substances, adrenaline acid tartrate. This is the percentage in substance and this is the FD 1% value. Second is sodium metabisulfite. And the third thing is sodium chloride quantity sufficient that we are already adding. No need to understand it in very deep sense because we know that this is quantity sufficient. Why written here? Because we need to add this to whatever quantity it's required. We need to add it to make it isosmotic. But its FD 1% value is also given. This is important because we need the value FD 1% value of this NaCl as well. And then water for injection to 100 ml. The quantities are going to be same most of the times. If they are not, you need to do some simple calculation, maybe related to some chapter 1, 2, 3. But for here, and I think they are not going to confuse you over this. They want to test that you know this formula or not. Now let's start putting the values here. As we are talking about FD 1%, what is the value here going to be? 0.52. So 0.52 minus, then a bigger bracket. Now what the formula asks for? Percentage of A substance. For example, we take this as substance A. So percentage of A means concentration in percentage. Now this is a point where they can trick you a little. Maybe they are giving you the value in grams, maybe in weight by weight, maybe in ppm. You need to convert it into percentage. That's it. No other trick they are going to apply, I think. Now 0.18% and now multiply it. In the formula we are multiplying it
FD 1%.
Yes, FD 1% of A. This is FD 1% of A, 0.098, and bracket close, small bracket close, and then we need to add it because there is add sign here. Now for the second ingredient, we'll do the same. This 0.1% because we need a percent here, percentage here, percent multiplied by what is its FD 1% value,
3.386.
0.386, and that's it. If there are more ingredients, you add it, but they won't give you much ingredients. Maybe they will give you one or two. Then in the down, we need to add the FD 1% value of this adjusting substance. This is it. What is our adjusting substance? Is NaCl. What is its FD 1 value?
0.52.
0.576. So that's it. How you add values to this formula. Is this difficult? All the values will be given here. One thing they can trick you is this, because here the percentage value is required. Percentage means out of 100 ml. Maybe they are giving you the concentration, for example. Now this is clear how you translate the values into a formula. समझ भी आई है किसी को कुछ?
जी
Yes,
जी
sir.
जी यस यस सर क्लियर
ठीक है. अच्छा, only one thing there can trick you is like this. Water for injection, now the total concentration is 1 liter and we need to add percentage here. Not if this is in 1 liter, be careful. The percentage means out of 100 ml. Here in this question that we have solved, they have already given us 100. But in the above question, they have given us the total volume in 1 liter. So we need to convert this 1.8 gram into percentage. This is very simple. I'm going to let you guys do this so that you will have more practice over it. Very simple. Rest of the steps are same. So be careful of this thing, percentage. Rest is going to be very easy. Now moving on to the next formula,
Okay,
where
sir,
they
एक
will
चीज
give us.
पूछनी थी. I have a
जी जी.
question. सर ऊपर वाले क्वेश्चन में आप देखिए तो दो इन्होंने वैल्यूज. अच्छा, ये जो NaCl है, ये भी तो कंपाउंड है ना, तो हम इसका एडिशन करके ऊपर इसका क्यों नहीं लिखते कि परसेंटेज इनटू FD 1% अपॉन करके.
नहीं, आपको कोई जरूरत नहीं. जो
मतलब
क्वेश्चन में लिखा है वो करें. मैं देखता हूँ, देखें इसमें क्या लिखा हुआ.
जैसे
मेक द
NaCl
फॉलोइंग
का FD
सॉल्यूशन.
और जी डालने की जरूरत नहीं है, वो भी तो कंपाउंड है, वो भी तो पार्ट है इसका. तो उसको नॉमिनेटर में ऐड करने की जरूरत नहीं है along with other ingredients.
यहाँ पे नीचे, यहाँ पे चले हम ऐसा करते हैं,
नॉमिनेटर
हम
की
इसको
बात कर
सॉल्व
रही हूँ.
करते हैं.
नॉमिनेटर में
मैं
आपने जो
बता.
है ना %A और उसका FD% फ्रीजिंग वो करे ना डिप्रेशन, दोनों कंपाउंड्स का ले लिया, तो फिर तीसरा कंपाउंड
जी.
NaCl भी तो है, उसको भी तो नॉमिनेटर में हम ऐड करना
नहीं नहीं
चाहिए
नहीं
ना.
नहीं, वो हमारा ये तो हम डाल रहे हैं. ये तो हम ऐड कर रहे हैं ना. इसको सिर्फ यहाँ लिखें और इसकी ये वैल्यू आएगी सिर्फ. ये ऊपर यहाँ पे इसको नहीं लिखना आपने.
वो एडजस्टिंग सब्सटेंस कोई भी हो सकता है, उसको हम नहीं डालेंगे कभी भी नॉमिनेटर में.
एडजस्टिंग सब्सटेंस यहीं पे आएगा सिर्फ, और इसकी वैल्यू यहाँ पे आएगी. एक्सेप्ट
ओके,
फॉर द थर्ड
ये
फार्मूला.
देखिए.
थर्ड फार्मूला में अंदर थोड़ी सी चेंजेस होंगी. अच्छा, ये अब आपने खुद करना है. ये इसके अंदर कुछ भी नहीं है.
हाँ,
क्वेश्चन
ये थोड़ा
10.2 के
आसान है.
अंदर इसमें सिर्फ आपने 1.8 ग्राम इन 1 लीटर है, इसको आप कन्वर्ट करें. हाउ मच इज गोइंग टू बी इन 100 ml, और ये इसकी कंसंट्रेशन बन जाएगी परसेंटेज, जो कि 0.18 बनेगी.
ओके.
अच्छा, moving forward, let's see a question where they have given us SCE. Everything is going to be the same, just the values are going to be in SCE this time. What example 10.4. Okay, let's see here. Now the formula where they give us values of SCE. Whatever the value they give you, you just apply the formula corresponding to it. How much NaCl is required? Again, they are asking us to add NaCl. is required to adjust 100 ml of a 0.5% solution of methoxamine hydrochloride. SCE values of NaCl is given, SCE value of methoxamine is given. Now the values of SCE will be given instead of FD1%. Now let's start putting the values in our formula. The percentage adjusting substance is NaCl is equal to, now the value is going to be 0.9 in the formula. 0.9 minus, now what is the only substance given other than NaCl is methoxamine. Methoxamine HCl. So what is its percentage? 0.5%, already given in percentage. 0.5 multiplied by, what is the SCE value of methoxamine is 0.26. 0.26, and there is no other ingredient, otherwise we have added plus and added another bracket and so on, but we won't do it for now. And divided by the SCE value of this adjusting substance. SCE value of this adjusting substance is 1. Now you solve the formula and you will get the answer. That's it. So same like FD1, but the values will be given in
0.77 is the answer.
Sodium chloride, yes, 0.77%. So the SCE value will be given, you will be using this formula. Now the third one formula is a little different. How? Let's first understand why is it different and how is it different. In the above formulas, we were using first of all this 0.9 thing. Now we are using 1. Just remember the value 1. Whenever they give you the values of CISO, you will be using value 1. Now minus is same. This bracket is going to be the same. And this internal bracket is going to be a little different, where we were multiplying it. Now we are dividing it. Percentage of A divided by CISO of A. Here we were multiplying it. Now we are dividing it. Again plus same and then other bracket. All the ingredients, we will be modifying the formula this way. And where is this thing going? SCE or FD1% of substance. This is moving on this side of the equation now. Percentage adjusting formula divided by CISO of this adjusting substance. Is this clear? What is the modification in this formula of CISO?
Sure.
Okay. Now let's practice it. One question for this as well. Now take a look at the formula. It's we are simply going to translate the values. Now how many grams of NaCl, again NaCl is here, are required to make the following eye drops isosmotic. Now this is phenylephrine, zinc sulfate, and sodium chloride. Sodium chloride we will be using here. So 2 ingredients are there. Let's start. Now this time divided by CISO value 3 plus, and then this second drug zinc sulfate 0.5. The values are already in percent. They given if they are given the values in percent, it's okay. However, no matter what is the final volume, 60%, the percentage is percentage. It's okay if they are giving it in percentage already. 0.5 divided by, what is it, CISO value 7.65, and that's it. And here we need to add the CISO of adjusting substance, which is 0.9. So we'll solve the equation and we'll get the answer. That's it. These are the formulas. I'll send this picture in the group. If I would have let all of you to write these formulas, but this is going, I know this is going to take some time taking process to write all of this formula again and again. So I will share this picture in group. These are the formulas that they are covering all the chapters, and one point I told you they can confuse you is this percentage thing. Maybe they are giving you values in some other units and you need to convert it into percentage. That's it. All the other things are going to be simple. These above formulas are also very simple with single statement, single short statement questions. Now, is this clear?
सर जो आप बोल रहे थे कि किसी और टर्म में मतलब परसेंटेज किसी और चीज में दी होगी, वो थोड़ा एग्जांपल देंगे थोड़ा।
हाँ जी, यहाँ पे हमने एक एग्जांपल देखी थी। ये अब यहाँ पे क्या दिया हुआ है, NaCl की क्वांटिटी जो सोल्यूशन दिया होगा पूरा, उसके अंदर अब हम बात करेंगे। NaCl दिया हुआ है 1.8 ग्राम और वाटर फॉर इंजेक्शन 1 लीटर है। अब इसका मतलब ये है कि 1.8 ग्राम 1 लीटर के अंदर हुआ, ये
तो
परसेंटेज नहीं बनती।
0.18 आएगा।
आप इसको क्रॉस
पॉइंट
मल्टीप्लाई इसको करें ना, अगर हम इसको करें
मतलब 100
कि
ml के अकॉर्डिंग करना।
100 ml के अकॉर्डिंग करें, क्योंकि जो परसेंटेज होती है ना वो आउट ऑफ 100 होती है। परसेंटेज आउट ऑफ 100 होती है, तो हम 1.8 ग्राम इन 1000 ml, तो x इज गोइंग टू बी इन 100 ml। ये आप कर लें तो ये किधर चला जाएगा। अगर मैं विदाउट कैलकुलेटर भी करूँ तो इसका आंसर 0.18
सर ऐसा ही
इन
आएगा, कोई और भी
100।
हो सकता है।
मोस्ट प्रोबेबली तो ये भी नहीं आएगा, वो सीधा सीधा आपको देंगे। वो आपको जस्ट चेक ये करना चाहते हैं कि आपको ये फार्मूला आता है। और वैसे भी एक चीज आपको बता देता हूँ मैं। अच्छा, ये चीज पता लगी आपको, ये कैसे कन्वर्ट किया हमने? ये 1000 ml में था तो हमने इसको 100 ml में कन्वर्ट
यस
कर
सर,
लिया,
थैंक यू सर,
तो जीरो
ये
पॉइंट
पता
वन
चला।
एट परसेंट आएगा। अच्छा, ये पता कौन सी चीजें हैं? चैप्टर 1 2 3 वाली चीजें हैं बस। जो इस चैप्टर की चीज थी ना वो ये फार्मूला थे। इसके अलावा अगर इससे पहले कुछ करने के लिए देते हैं या इसके बाद कुछ करने के लिए देते हैं, फॉर एग्जाम्पल ये भी पढ़ लेते हैं यहाँ पे। इन्होंने एक एडिशनल स्टेप यहाँ पे किया है कि 4.12% का क्या मतलब है। तो इन्होंने लिख दिया यहाँ पे कि 4.12 ग्राम इन 100 ml। तो एक स्टेप और आगे चले गए, अगर दिया पूछा हो आंसर के अंदर। ये तो वेरी सिंपल है ना, ये तो अब सब लोगों के फिंगर टिप्स के ऊपर आ गया कि 4.12% का क्या मतलब है। 4.12 ग्राम इन 100 ml। तो अगर 1000 ml के अंदर एंड पे भी जाके आपसे पूछ लेंगे तो आप उसको कन्वर्ट कर दें। वो जो ये छोटे छोटे जो स्टेप्स है ना, चैप्टर 1 2 3 वाले जो है, ये इनके अंदर जस्ट लाइक अ ब्लॉक्स ऐड हो सकते हैं कि एक मेन आइडिया है क्वेश्चन का, उससे पहले या उसके बाद वो आपको कन्वर्जन के लिए दे सकते हैं। जैसे आपने मोल्स के क्वेश्चन किए हैं मेरे साथ, तो वो एक जो ऊपर छोटा सा राइट साइड पर बॉक्स बनाता था ना मैं, कि यार ये तो एक क्रॉस मल्टीप्लिकेशन करने वाली है, ये आप पहले ही कर लें, बाकी ये कॉन्सेप्ट ये है। तो हर तरह के क्वेश्चन के अंदर जितने हमने किए हैं फ्रॉम चैप्टर 4 5 to 9, उनके अंदर मेन आइडिया होता है एक, और उससे पहले और उसके बाद में मे बी एक आपको छोटी सी कोई क्रॉस मल्टीप्लिकेशन या कोई कन्वर्जन फ्रॉम PPM टू परसेंटेज इस तरह की करनी पड़े। तो वो जब आपकी क्लियर होंगी ना तो आपको डर नहीं लगेगा। आपको मेन आइडिया आना चाहिए, उससे आगे या पीछे आपको कोई भी वो प्रॉब्लम सॉल्व करने के लिए दे देते हैं छोटी सी, तो यू शुड बी एबल टू डू इट। और विद प्रैक्टिस आपको पता लग जाएगा। यहाँ पे ये मैंने चीज आपको इसलिए नहीं करवाई कि आप जब खुद प्रैक्टिस करेंगे तो आप इसको करेंगे। वेरी सिंपल है, मे बी पार्ट ऑफ द क्वेश्चन, मे नॉट बी पार्ट ऑफ द क्वेश्चन। अब मैं आपको एक चीज दिखाता हूँ हमारे पास कुछ मिनट हैं। ये जो पहले 3 चैप्टर है ना, यूनिट्स एंड कन्वर्जन, परसेंटेज कन्वर्जन, डेंसिटी एंड स्पेसिफिक ग्रेविटी, ये जब कर रहे थे उसको तो बड़े सिंपल लगे होंगे आप लोगों को कि ये तो बड़े आसान आसान से क्वेश्चन है। लेकिन क्या होता है कि ये अकेले कम आते हैं। अम, या तो ये कॉम्बिनेशन होगा कि एक ही क्वेश्चन के अंदर आपको 2 दफा क्रॉस मल्टीप्लिकेशन लगानी पड़ गई, एक दफा आपको परसेंटेज लगानी पड़ी, एक दफा क्रॉस मल्टीप्लिकेशन लगानी पड़ी, इस तरह के क्वेश्चन होंगे। और मोस्ट ऑफ द टाइम्स आपके यही चीजें, ये जो हम आगे वाले चैप्टर्स में करते हैं ना, मैनिपुलेटिंग फार्मूला, वेइंग, मेजरिंग, डाइल्यूशंस, बॉडी कैविटी, मोल्स, मिली मोल्स इक्विवेलेंट, और आज आइसोस्मोटिक, इनके अंदर पार्ट ऑफ द क्वेश्चन भी होंगे। So main idea is going to be one for all these chapters from 4 to 9. These are the most important ones, and this 1 to 3 are the basic building blocks of all of these calculations. From chapter 4 to 9, there are going to be one main idea, one main formula to be used, and then maybe at the start of the question or end of the question, they can add some cross multiplication. That's it. So these chapters are most important from 1 to 9. From this chapter 10 that we have done today onwards are 11 buffer solution. This is also very small, just couple of formulas that you need to memorize, and all questions will be easy. Then drug stability, little tricky, but depend on a couple of formulas, that's it. And then molecular manipulations, simple common sense questions, physiology, simple common sense questions. Also, these are not that important. From 10 to 14 are not that important. If you have learned this chapter 1 to 9, that means you are able to pass your calculations part of KAPS. But we will do it as they are simple, not much complex. You just need to memorize a couple of formulas and you will be able to solve it. So that's it for this session, my friends. You just need to practice all the questions given in this chapter from the Monash University file first, and then from the EPIC. So I'm going to end this session now. If you have any confusion, we can discuss in next session, but I believe you won't when you will practice by looking at the questions given in the Monash University lectures. All right, guys, I'm going to finish this session now. Thank you for being here.